Hi guys, so what we are actually up to today is having made a macro keypad. So you can see the thing over here, and we'll be going through how I created that, software, hardware, and all that kind of stuff. And as we're talking about this, in the top right corner you will see some background video where I actually are creating the PCB for it. I have videos on PCBs already, so you can watch those if you want to get details. It's pretty easy process. In any case, why I actually were doing this is, let me move this over a little bit. Why I'm actually doing this is because I have limited space in my workshop here, and this is my lab bench. It's the only one I have, and it doubles as a also for my computer. And sometimes, especially when I'm writing code, like even Arduino code, like we'll be looking at today and so on, I need a keyboard. So what I've done is I've got a little sliding tray over here. As you can see, I can push it away and then move it back in. And when I'm soldering and doing stuff, of course, I just move it out of the way. But this keyboard over here, it only has insert, delete, page up and page down, and when I'm editing I quite often need home and end and a few other keys that would be useful to have. So I got the idea, since we already know now how to create a Bluetooth human interface or a HID device, that I could make this little keypad over here. Now I also got the idea because on the if you look at AliExpress and so on, you'll see tons of these little keypad devices. Some are bigger, some are smaller, some are very small and as little as $4, $8, some are $20 or even more. And of course you could buy one of those things and maybe you would be able to use it. Some of those come with rather hokey software with them, which makes them a little bit hard to use, and of course some of them just got keys of 1, 2, 3, 4, 5, 6, 7, 8 on them and so on, and you'd have to assign features to those and remember what they are. In any case, I then started to have a look and I came across these transparent keycaps, which is what I got, because you can put little, with my label maker I can put on there what the keys are actually going to be. And then I found these switches over here, and they're kind of nice, and they have the same footprint as cherry switches, and I actually got the green ones over here on account that I like heavier keys and I like them clicky. And if you look at the features over here, they have 65 grams of force or something, and whatever, they are a little bit sturdier feeling, and I like that. So I bought 10 of those, and this is what we're at. So then I got the idea to also, just like on a standard keyboard, you can have like a shift key or alt or a function key and so on, and to make the keys on the keyboard actually do different things. So that's what I ended up doing. Each key over here basically has 3 different functions, and the 2 main functions are printed on the top here. So this is the home and end buttons, the ones that I really wanted if you use them, and all the ones on the top here are the main functions. But if you hold down this function key over here, then it'll produce these bottom functions. And of course I had to abbreviate those to make the text be readable and fit on the top of these little keycaps. But of course, to me, that I know exactly what they do. This is home and end on the same line. This is top of the file, bottom of the file. This goes to the next line. This will toggle a comment on the line on and off. This one does too, but it uses a different comment character. It's like a global comment. And we have here, this one selects a line. This one copies the current line above it. This one copies the current line below it. If you hold down the function key, it is the find and the replace functions. I've mainly aimed this at using Visual Studio Code because I'm in there most of the time to edit, Arduino code using Platform IO, and also if I happen to be editing HTML or whatever, I always do it in mostly in Visual Studio Code. I do use Visual Studio for C# programming, and some of those keys wouldn't operate in there because they have different key codes, but I don't really tend to use those some of those functions there anyway. So what have we got here? Insert a line, delete a line, rename a symbol like a variable, trim trailing spaces from the end, and this one here, it actually outputs print screen, but what it does is I've got my system set up. If I hit that key, it will bring up the screen capture, so I can take a screen snip and so on, and save it and so on. If you hold both function keys down, that's why it says FN2, then these 8 keys here get yet a third implementation. So let's have a look. We've got some text here, so I can actually put let's put the cursor on this line here. It's right on that word same over here now. If I hit this key here, oh, I haven't turned it on. So while we're at it there, I have an on-off switch over here. This is a spare port. You'll see it when we look at the circuit that I can put a connector into to get the spare I/O ports, mostly for SPI interface or something like that. On this side here, I've got a USB-C port for actually charging. There's a battery in there. This was I originally put a hole there for a switch, but I ended up not using it. I didn't have a switch sort of small enough. There was not enough room, so I used this little slide switch instead. Actually, better idea anyway. And over here there is the actual port from the ESP Xiao ESP32 S3 board, so I can actually program it, because this thing actually is going to double as my a little board that I use for development as well. I don't have to have the keyboard code in there. I can actually upload other code to it, and besides, I might want to make updates to this thing and maybe change some of the keys if I use it for a while and I find out that there's a feature missing and some I don't use. I can change them. In any case, that is what it is. So did I end up tuning it on? No. Okay, now it is on, and so we will find that we should be able to see it in a Bluetooth now because I've turned it on. Yeah, my macro pad here is connected. That's what it is. So as I said, if I hit home, you'll see now it went to the beginning of the line, and if I hit end, it goes to the end of the line. And if I hold down the function key and I hit it, it goes to the top of the file, function key, end goes to the bottom of the file. And putting the cursor back there, I can select the whole line. I can go to the next line. This is kind of handy because sometimes on some editors, especially our little trackball, and it's a little bit touchy, it's sometimes hard to actually get the cursor right in front of the first character, so I can hit that instead. I can actually, let's take this little line over here, copy line above. See, it goes above, copy line below. So it copies it and puts the cursor below it. Let's hit Control Z or Z, get rid of those things because I don't want to save that. What else have we got? Oh, then we have an insert a line. Let's put it back here, you can see it easier. So that inserts a blank line, puts a cursor at the beginning. This deletes the line. Now, if we are actually in code, then you will find that I can hit delete line. It will just blank it out, but it doesn't remove the line. But if I hit it again, it goes to the beginning and then it deletes the line. So that can kind of actually be kind of handy. Now, it is also interesting since we're on that line there. Now, if I hit the function key here and say hit this comment key, it comments out that line. Hit it again, it uncomments it. This one over here will actually use a different kind of comments, or like a block comment. If I don't have anything selected, you see, sometimes it can be difficult to put the cursor in the front of the line there, so then I can actually hit. This is one of the cases where I would hit the home key like this. Alright, so if nothing is selected and I hit this key, then it'll just insert those two little characters instead. Hit it again, takes them out. If I hit this, it'll go to find. You see it's at the top there. If I hit that one, it'll actually bring in the replace. Hit escape to get out of there. And if I highlight something like a symbol, like this a variable, and I hold this down and I hit the rename, brings up that little box here. Now I can type a new name and then it will actually end up renaming that variable wherever it is used, which is handy. Escape to get out of that. And that's kind of how that works. Now if I push both function keys and I put some, just for testing, I put some code in there that you might commonly use in Arduino. Stuff like that. So I thought, yeah, could be handy. So let's just, you'll see where that comes from in a minute. Alright, so interestingly too, if you are in a different kind of file, like this README file is actually sort of formatted as a, I don't know, some sort of maybe like a HTML format or some sort of format. I'm not quite sure what it is, because it doesn't have an extension on it. However, the editor knows, and if I go in that line here and I hit that thing to comment it out, it knows not to put two little slashes there, but in case it in like this HTML type comment. It's interesting. The Visual Studio Code's got it's evolved to be quite a powerful editor. Anyway, so that's how it works. And so let's have a look at the well, since we're in the code, let's have a look at the code first. So what I've actually done is I put most of the code in MacroPad H and MacroPad CPP. and the reason being that I probably will turn that into a library at some stage in the future, and then it's already in separate files. So therefore, also the main file here is very simple. It's got a setup, init macropad, loop, scan macropad, and the only other code in here is the advertising for the BLE Bluetooth. Bluetooth actually advertises itself, to anyone that is listening. It says, "Hey, I'm a HID device, I'm a keyboard," and that allows you to pair it, and if it's already paired, it'll connect. So it says, it's very quick. It's like less than a second. I turn it on and off, and it's connected almost immediately. So it works pretty good. So therefore, the header file, the macropad hates, is a lot of the code is. What you will see there is that there are up to 10 keys, and I store and capture the key state. And if one of those is true, that means that the key is currently down. It's been pushed in, but I don't respond to the key until it's released again. That helps, so not to get key bounce, and also I don't want to have a repeat function. So that actually makes that work. We have a structure here where I can store the modifier, a HID key code, like a scan code for the key, and up to 64 characters of text, and also the actual over here is where that is used. You'll see that there is 4 items. It's a 2-dimensional array with 10 keys with 4 dimensions for this stuff over here. So when you hit one key and release it, it can output potentially up to 4 keys with 4 modifiers like Shift, Alt, Control, and so on. Over here, it kind of tells you what it is, but there is better reference to it over here. As you can see, bit 1 Control, second bit Shift, third bit Alt, the fourth bit is the Windows key. That's on modern keyboards, also a Shift key. So you can have up to 4 of those output through Bluetooth as you release the key. So that makes it a macro pad, because you can kind of create macros, one key press and it outputs a bunch of stuff. But it also has up to 4 64 character strings. So that's a total of 256 characters or something, or 200, something like that, if need be. And so we have, as I said, 3 levels. First, without the function key down, we have these are the default ones. Here, so hit key end, hit key home. These are the keys that don't exist on my keyboard. But this one, of course, is a select line, so it actually does a hit key home, a modifier of 2, which, remember, is Shift, and when you do that, you go home, and then you say end with the Shift key down. It actually selects the whole line, and you saw it happening when I push the key. And these other ones are 0, so they don't output anything. Copy line down is actually arrow down with Alt and Control, I think. Is that what it is? Shift Alt. Anyway, that is how that works, and there's a bunch of just ordinary key codes there. If you have the function key down, it selects from this list over here, and it's a similar thing. It just outputs mostly key codes for that particular key. Here number 4 is not used, because that in that mode that also becomes a function key, so it doesn't actually function as a there's a key in that mode. And then the third mode, this is where that text came from. I'm actually only outputting text here as an example. I just picked some like Arduino type of C++ library commands: digital write, digital read, serial print line, pin mode, hash define, hash include, uint 8t, common things that are used. And you saw that worked when I held both the function and the number 4 key down. The keys are actually numbered in this manner here. The first row is 0, 1, 2, 3, 4, and the second row is 5, 6, 7, 8, 9. So that's how the keys are ordered. And then there is scan macropad and init macropad, and of course that is in the CPP file. Initialization, just the standard stuff, sets up the pins, modes for the D0, D1, D2, and D3. These are used. I've got a 74150 multiplexer in there that I'm using to actually connect each key of the keyboards to. We'll look at the circuit. That's strictly speaking not entirely necessary. If you're building something, you could connect these the switches directly to your microcontroller, especially if you're using a larger microcontroller that has many GPIO pins. But we'll look at the circuit now. I'll tell you why I did that. And then there is D7 is an input, and D8 is an output. So we are scanning the keypad. This is the key number, remember 0 to 9, and it will, for each bit in the number, it will actually enable D0, D1, D2, D3, which is the 4-bit binary number actually that is being sent to the multiplexer. The multiplexer then will actually select the one of the 16 inputs, but we're only using 10 of them, of course. D8 is a strobe on that chip, so we will actually strobe it from low to high. Well, we strobe it to low so that then we could do a read on D7 to read what the state of that switch is, and then we write D8 back to high. And then we're capturing, if the read was low, then is down is true. And just a little thing here to determine what the current function mode is. So should we select keys from the table 0, 1, or 2? Here we process the key and the text. This is the actual scanning of the micropad. So depending on the function mode, we will select from the table 0, 1, or 2. And the mode gets, when it goes to the loop, it actually goes to the mode first. There's a little bit of stuff here to make sure that if you got both function keys, like the 9 and the 4 key down, and if you release the 9 key first, then we need to not trigger key 4, which also has a function when it's not being shifted. So that's a little bit extra code there. And then we actually send the input report. But that is the Bluetooth code that actually outputs the keys and the modifier key in a report. And that's it. That's the all the code. Okay, so circuit is actually relatively simple, but I put some extra stuff on there just for good measure. There's some input circuitry for the power. Remember, you saw that there was I've got a USB-C input power port there, which actually just has some pads on the PCB, because it's got wires to connect it. I'm using one of those, was it PPTC, whatever you call those things. It's like a special kind of fuse that will actually, if it tries to draw more than 500 milliamps, it will actually become high resistance, and then when the power is removed and it cools down, it actually opens up again, so you don't have to replace it. That's just a safety feature. And I put a couple of capacitors on there, 220 microfarads and 100 nanofarad for decoupling. This thing here is a socket I put on there, and I haven't used it, and I'm not using it for anything right now. For a 24C64 or 128 or whatever, it's an I2C little flash memory chip that is very common. I thought in future I might use that on this kind of board. I got all sorts of interesting ideas too. I might make it addressable via Wi-Fi, then you can upload actually key codes and things to it, switch modes and stuff, and you could store them in here. So anyway, it's just something I might try in the future. I don't even know if this will work. In some instances you need to have pull-up resistors on some of these pins here, and I need to look into that. But I'll put a socket on there and potentially connected those pins to the SDA, SCL and WP pins over here. So then the actual key switches are coming in through a little header over here, which is on a different circuit. We'll look at in a minute. Because I decided to make two PCBs, one above the other, one with the keys on it and one with the circuitry on it. It's potentially possible to put it all on one, especially if you don't have the socket for that on there and you're not using this multiplexer. There was a little header on there, remember I showed you, there's like 6 pins there, plus 5 ground, 3.3 volts, and the spare pins there that were on the chip there, although SDK and D8 is used now. Originally it wasn't, but I'm using it now. So this of course here is the Xiao ESP32 S3 little board, and that's the output that it has. So over here we have this 74150. Reason I'm using that is because I had 3 or 4 of those in a box. They're like 40 years old or more, I don't know. Bought them when I was a young guy doing electronics. So the first 10 inputs here are used for the 10 switches that we have. The other inputs, D10 to D16, are not used, and we just connect them to ground. And if you look at the truth table for this thing, it says, oh, if strobe is low, then when you select an address here, then it'll output on this pin 10 over here, W out, it'll output whatever the value of the input is, except it's inverted. But I found out that that didn't work, and I then, just experience over the years, I thought, you know what, maybe this thing is called strobe. Maybe that means that it needs to have a signal over here before the output actually becomes reliable. And I mean, it sort of did something, but it wasn't reliable. It would come back with weird information when you change the address. So that's what you saw in the code. I make this strobe high normally, so it doesn't actually present any output. And then when I set the address lines, and then I make strobe low, and then it would actually start to output the data on that output. It's actually inverted, and of course it's 5 volts, but we want 3.3 volts for for the Xiao microprocessor. So therefore I use the field effect transistor here to level change it. Remember, I did a video on level changing, and that was one of the options that you could use. And I thought myself, let's try that out, make sure that what I said was true. And it works just fine. So and it actually inverts the output again, so now the output is actually not inverted anymore too, so that's convenient as well. And so therefore D out then connects to D7 on the Xiao chip. Oh, just an additional word about this circuit. I meant for this thing to be a bit of a test bed, so I can actually run code on this little Xiao ESP32 board, and I thought I might extend it or something in the future, and I wanted to keep some of the output GPIO pins for a future expansion perhaps. So I wanted to expand the ports that it has, so by using this multiplexer, and of course there is many other ways that you can do this. I did a video on port expansion. There are a number of different chips and everything. I just happen to have these old 74 150s laying around, and I thought I'd use that, but there are better chips now available actually to do that as well. But in any case, you see this thing only uses the AO 1, 2 and 3, and of course there is some D7 and D8, so that's like 6 GPIO pins. If I connected all the switches to GPIO pins by themselves, there would be 10 that would be needed, and this way I had 1, 2, 3 potentially, as you can see over here, GPIO pins still available, which happens to be the ones for the SPI interface. So I can hook something up to it with those pins with whatever I want. And I put 3.3 volts and ground and 5 volts there on the expansion port. However, if you are only just making this kind of circuit for like a keypad, you wouldn't even need that socket over here that's also connected to SDA, SCL and WP. They would be available as well, and if you actually count all these pins, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, you've got 12 GPIO pins available, so you could actually hang the or connect rather the keys directly to those pins, and you wouldn't need this multiplexer at all. So I just thought I'd mention that as well. So now let's have a look at the keyboard bits. Oh, well, before we do that, of course, this is the PCB that I laid out for it, and this is what we are using. So now let's have a look at the other one. This is the bottom board. Okay, so this is the little top board with the switches on it. Not much there. Just each switch has a pull-up resistor, and just connected to ground, and that then connects to the header over here, switch 1, 2, 3, 4 to switch 10. And this is a PCB for it. This is just a prototype, and I use junk parts that I didn't want to. That's why we're using these resistors over here. I've ordered some more switches, and I think I might make a little dedicated keypad, because the one I've made over here, I want to use it as an experimental unit. I can actually use the little Xiao board and they use it like a breakout board with switches on it. So then I can use SMD components, move these switches closer together, and I think I can actually get it all on one board, I believe. So that is what that is. And okay, so the little box that I made for it, as I said, I did a fast print on I got a Snapmaker printer, 3D printer, and that's why, you know, it's a little bit rough, but I didn't want to wait 10 hours for it to print out in high density mode, so this is plenty good enough for me. I actually used TinkerCad to make this up. I find that TinkerCad is kind of quick and dirty. I could use Fusion 360 or some of the other CAD software, but they are of course much harder to use, and for something simple like this it is actually easier to use. See, there it is. Only one little mistake, and that is this hole over here is in the wrong place. That's why I had to cut it out and make it lower. I don't know what happened there. Must have mismeasured it. So I need to, if I want to print out another one, I'd have to make adjustments to it, but I don't expect to have to print it out again anyway. But that's what I used, and then it you just export it to an STL file, and then I use Cura for the 3D printer. Okay, so that's all I have to show how this thing works, and a bit about the software and the circuit and stuff like that. Next, we will be looking at the next part of the video. We'll be looking at how I built it, soldering up some of the components and things like that. And if you're interested in that, then you can keep viewing, and if not, then you could stop the video here, and I hope you enjoyed it so far. I will put links in the description, and might put the code on GitHub or something like that in case you're interested in that. And then I hope to see you in the next video if you're not going to watch the rest of it. And I still hope you will subscribe and like and all that kind of stuff. But in any case, if you want to see how I built it and get to know more about what's inside, then keep viewing, and I'll be glad to have you with me for that. Okay, so we've made up our little PCBs over here. Got two of them. This is the bottom one. This is going to be the one with the switches on it. So I'm going to do this one first so I can test it, because it's the simplest one. And I'm going to be mounting these little resistors on here. So I guess all I have to do is to poke them through the little holes here, like so, and then I will be able to turn the board around and solder the little legs on. So let me poke them in off camera, because that's going to be boring to watch, and then we'll go and solder them on in a minute. Okay, I've poked them in, so now we're ready to solder them up. Okay, I'm going to use a little bit of liquid flux, because these resistors I've used in breadboard projects before and so on, so who knows what state they're in. They might have a bit of corrosion on them, who knows, so a little bit of flux will not hurt. I'm just using ordinary liquid rosin flux here. A tiny little bit is all that is required. Now let's have a look. I think I can use my 50-watt iron over here. Should be powerful enough for that. And what have I got for the way of solder? I'm going to use this old solder here. Okay, that is the resistors are on. So now we are going to do these switches. Now, when I laid out the board, I set these switches up for cherry switches, and they must have the same pinouts because they seem to work just fine. And they go on like that, and there's a pin that goes to the bigger holes there. So again, I will poke these in off the camera, and we'll solder them on. And then we can test to see if this little board is working, because that's all that's on there. Alright, so they're all fitting on there. Now we're going to be soldering them on. However, some of them are a bit loose, they're going to fall out, so I think I'll put a little bit of tape on them to hold them in. Actually, I think what I'll do is I will just solder them on one at a time and hold them in with one finger. Okay, that should do it. So let's give it a little test here with the multimeter. Got one connected to the ground plane here, and this is switch number 1. It's working. This one is working. That one is working. That one is working. Okay, they're all working. Very good. Let's put the little caps on. Make it a bit easier. Now they've got some clear caps that go on over the top of them like that, so I can actually put some my label maker, put on there what they're going to be. But for now, for testing, they don't need to have anything on them. Now this board, since it's only single-sided, it's going to have some wires on there, and you can actually see that. I bring up the circuit here, and I'll take the blue stuff is underneath, and the red stuff is on top. You see all those red traces is where wires are going to have to be put in. If you have a double-sided PCB, of course, they would be little vias with traces on the other side, but since I have to fudge it with wire, so I'm going to be putting those in, and I'll do those off camera mostly. It is pretty simple. Let me get rid of the display here. So I use this bus wire over here, and now let's have a look. There is a, oh, in case you guys are wondering too, this is the little board that's going to be mounted over here, and you may be wondering why there's a big hole there. What I'm going to do is I'm going to put a battery in there, and these little boards have a connector for a battery, the battery plus and battery minus. I'm going to be soldering some wires on there with a little socket or something, and that happens to go, the hole sits right over top of those pads, as you can see. That's what that's all about. So let's have a look. There is a wire going from here right up to there. There we go. So that is how it is going to go. I'll straighten it out a bit and just solder them on the other side. So I will do those. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 wires to go. Or 8 to go rather, there's 9 in total. Okay, I have the wires fitted, and I've also had to mount these little components here because one of those wires, I forgot to drill a hole for them, and for some reason it's too close, and so I put some insulated wire there, so I had to know where the components went before I could do that. So now we should be ready to put the other, like the socket over here and so on. But first I need to find out in which direction that goes. Off camera here, I'm actually looking at the circuit. Pin 1 is at the bottom. fact, we can put a little mark there, can't we? This is pin 1 over here, and what about the big IC over here? I believe it's also in that direction. Let me double check. Yes, indeed. Pin 1 is over here as well. Okay, so I got those two guys mounted, and we can actually solder those in place. Now this little transistor over here, I just gotta double check what the pinout of it is. Drain, gate, and source. Okay, so source, gate, and drain, so it's got to go in like so. Okay, that should do it. Okay, 10K resistor, that's there. And I guess while we're at it, we might as well poke these little capacitors in place. Those little bypass capacitors. Okay. Now, those holes here, I'm gonna put a cable that goes straight to the other side, and I may put some little headers on the other piece of it so we can separate the boards. I'm going to actually do some checking now with the multimeter to see if everything is connected correctly, and I'm going to do that off camera. Okay, so I have soldered on a little header over here but I've had to put it on the copper side, which means I had to cheat a little bit and raise it off a little bit from the copper side there and solder it underneath, which is okay for a prototype, but normally of course this would be double-sided and there would be pads on the other side and you could just solder it normally, but just for this prototype that will do. I have soldered on a little USB-C charge port so that we can supply 5 volts to it, and I have already taken some of this ribbon cable over here and I soldered them on to the board here, and I have put some Dupont pins on the end of it, and that of course will it will go like this, and then that would plug into here. So now we've got to do the second one. Of course, if I didn't do that, you know what will happen. Murphy's Law, if I just soldered both sides onto the boards, something won't work, and then I would have to take it all apart again and stuff like that. So now I can unplug it and fault find if there's any problems, which would be helpful. Okay, so for these pins I use these little Dupont shells, and we've got these little pins over here. They're actually not pins, they're actually little sockets, if you like, that these pins over here fit in, and I thought I would show you guys how I do that, just in case there is some interest in that. Now what I have is I use this these pliers here. They are iWis 3220M. Of course, you know, in the description there will be where I got those from. These are affordable and they are almost perfect. They could be maybe a tenth of a millimeter wider. That would make them even better, but they are good enough as it is, and they are cheaper. If you bought real Dupont pliers, they would probably cost an arm and a leg, because these companies, you know, they know how to charge, because they figure that they are supposed to be only used by companies, professionals, and spending a couple of $100 on a pair of pliers doesn't seem unusual for them, but for us, of course, that's not a good thing. So first I strip some wire off. Got these old pliers over here, which I've had for 40 years or more, and they still work well. I've got all these fancy ones that I've bought over the years, and they just don't seem to work very well, and I keep going back to this one. Let's do it this way. I think it's actually an Australian brand. I used to live in Australia for 20 years. Sturdy. That's why I got a bit of an Australian accent, because English is not my native language. I come from the Netherlands originally, but I was about 17, 18 years old when my parents immigrated to Australia, and I learned to speak English there. And apparently I did so well at it after a while that people used to say, "How come you don't have a Dutch accent?" They thought, when I was in Australia, they thought that I sounded like an Australian. And I figured that if you move to a foreign country and learn a foreign language before you are 18 or 19 years old, you can actually pick it up and become like a native speaker. But if you're older, judging from cousins and things that moved to Australia that were older, they always retained a Dutch accent. Anyway, that has been my experience. Okay, so with these pliers, what you want to do is you want to get the pin. There's some erased bits on there. And if we put this down, I can point it out. Where's my, here, little needle. So there are these little things on here, and they actually are meant to go around the insulation, and there's some little raised area here that is supposed to squeeze onto the copper to make a contact, and then over here there is a little square section that should stay open, because those little fingers in this these are kind of like little tangs. See, they can move. They will snap in there and hold it in place, so that's important. Alright, so what I do is I make sure that everything is straight. Then I can poke it in there. Now this insulation is actually a little bit thicker than what these little pins like to have. There, so now it is inside, and you just squeeze, and then if you look at it, maybe I can zoom in a bit more. Hold on, I just did another one, came out a little bit clearer. So you can see this is kind of got grabbed the insulation, and this is squeezed shut, and the little square bit over here is still empty. So anyway, I'll go and complete the others, and then all I have to do is strip a little bit of the insulation off here and solder it in place in these holes over here. Okay, so now we've got all these wires crimped on, and we should be able to poke them in. You make sure that the top with the, that little empty section like that goes in to meet those little tangs like that. Okay, so this one next. Now, as you can see, they catch those little tangs, those black tangs. They catch those little holes in there, and if they're in properly, they shouldn't pull out. But if they're not in properly, they do pull out. And a lot of the Chinese ones are not made that well. Usually, they're little leads and things, and they fall off. But let's have a look. Yeah, this is in the right way. Okay, so now I should be able to first get them started like that. And sometimes to help it along, you can use little pliers and making sure that they are pushed in all the way. So let's have a look now. Yep, they're all tight. They're not coming out. Okay, so I have tinned the little wires. So now we should be able to poke them into those holes over here. I'll do that off camera because it's going, when I'm moving it around, it's going to be blurred anyway. Okay, now we should be able to solder in these last few pins. I think that will do. And I'll also do this little one here. But the plan is to use these kind of course I still have to put on the solder this on here, the little ESP32, and I've got a solder. I'm going to use this battery over here for it, and I've got to make up a little wire that onto the battery pads, which will go through that hole, and but on the hole this will go on here. There we go, that's how it will plug in. And then we use these kind of things, these standoffs, and they will go through there, and of course there'll be two more on the other side, so we get a little sandwich. So I've got to put the nuts on there because they keep falling out right now. So that's kind of how it'll go, and it'll be like a little sandwich. And then I have to make on the 3D printer, eventually make a little case for it so that it can be housed in there. That will come onto the side. But for now, this will do very nicely. I can just have it like this for testing. And hit the keys. But next, we're going to put on the little microcontroller and get the battery hooked up. Okay, so that brings us to the end of the video. It got a little bit long. I tried to speed it up a little bit in some places, but that's how it goes. I hope that you got something out of that. As far as I'm concerned, this was a completely successful little project. I now have a keypad that I can use, and it's kind of flexible. I can program it to output any kind of text or control keys or whatever. I might even make an extended version in the future with a little display on it that I'll be able to access through Wi-Fi or something and switch different modes. In any case, that'll be fun to do as well. But for now, that's all we've got. Hope you enjoyed it. Don't forget to like and to actually hit the subscribe buttons and all that kind of stuff. That will help me along quite nicely. And we'll be looking at something more other interesting things in the near future. Okay, see you guys later. Bye bye.